Portfolio expected return and variance. Portfolio expected return is the weighted average expected return of a portfolio with n securities. Let's say we have a very simple portfolio which consists of two stocks, stock 1 and stock 2. Let's say that stock 1 represents 80% of your portfolio and stock 2 represents 20%. If the expected return on stock 1 is 10% and the expected return on stock 2 is 16%, then what is the expected return on this overall portfolio? The answer is that the expected return is the weighted average of these two returns. And that makes sense because clearly if the first stock represents 80% of your portfolio, then the overall portfolio return will depend a lot more on stock 1 relative to stock 2. So if we take the weighted average of 10% and 16% weighted based on how much you have in the portfolio, you will do 10% into 0.8, which is coming from the 80%, plus 16% into 0.2, so that is the portfolio expected return. To put this in general terms, we can use the formula shown here. The expected return on a portfolio is the weight of your first stock times the expected return on the first stock plus the weight of the second stock times the expected return on the second stock, and so on. You might also be concerned about the variance of the returns, and computing the variance is a little more complicated. We can't simply say that the variance of this is 25, the variance of this is 30, and we take the weighted average of the two. That does not work because these two stocks might move up and down together. It is also possible that when this stock goes up, this stock goes down. It is also possible that the movement of these two stocks does not depend on each other. So before we get into the formula and the discussion related to the variance of a portfolio, we need to understand the relationship between the returns on stock 1 and stock 2. Mathematically and statistically, those returns are expressed through measures called covariance and correlation. So let us understand these two concepts first before we discuss the variance and standard deviation of the portfolio. Covariance. Covariance is a measure of how two variables move together, and this is the somewhat complicated looking formula for computing the covariance between the expected return on stock I and the expected return on stock J. I will just say this briefly but then illustrate through an example. So the covariance between I and J is the expected value of this product. The first item here is the return of stock I under a given scenario minus the expected return of I, and then we multiply it by the return on J minus the expected return on J. We do this for different scenarios and then come up with the probability weighted average of the different products. Now that might have been hard to understand, but let us go through an example. Say we have two stocks A and B, and we are given the returns of the two stocks under different scenarios. There is a 15% chance or a 0.15 probability that we will have a good economy, and in that scenario the expected return on A is 20%, the expected return on B is 40%. There is a 60% chance or 0.6 probability that we will have an average economy, and in that scenario the expected return on A is 15%, the expected return on B is 20%, and finally there is a 25% chance or 0.25 probability that we will have a weak economy, and in that situation the expected return on B is 0 and the expected return on A is 4%. We now need to compute the covariance, and remember, covariance is a measure of how these two stocks move together. Just simplistically, if the two stocks go up together and then they go down together, that means they have a positive covariance. If they move in opposite directions, then we say that they have a negative covariance. Simply looking at these numbers, when the economy is good, both stocks do relatively well, and as the economy weakens, the performance is not as good. So just at a high level, it seems like the covariance is going to be positive. Let us now look at calculating the actual covariance number. To do that, the first step is to compute the expected value for the return on A, that is this item. So imagine that I is stock A and J is stock B. So we need to compute the expected return on A and the expected return on B. As you've seen before, the expected return on A will be 0.15 into 20 plus 0.6 into 15 plus 0.25 into 4, and that is 13%. The expected return on B is 0.15 into 40 plus 0.6 into 20 plus 0.25 into 0, and that is 18. Then to compute the covariance, we have to come up with the expected value of this product, and the way we do that is look at the first scenario, which has a 15% probability, and then this product here is the return on A minus the expected return on A in the first scenario where the probability is 15%. In the first scenario, the return on A is 20% or 0.2. So we have 0.2 minus the expected value of A, which is 13% or 0.13. We multiply that with 0.4 minus 0.18. Notice that in this scenario, the first scenario with a probability of 0.15, the return on B is 40% or 0.4 minus the expected value for B, which is 18 or 0.18. And then you move to the second scenario, probability is 0.6, and then we have 0.15 minus the expected value. For B, we have 20% here minus 0.18, which is the expected value. And then in the third scenario, 0.25 probability, 0.04 is the expected return on A minus 0.04 is the return on A in this scenario minus the expected value of 0.13, and then 0 minus 0.18 from here. When you do this calculation, you come up with 0.0066. This is a positive number as we expected, which means that A and B move up and down together. The formula that I've shown you here is the population covariance, and this is based on forward-looking estimates of the returns for I and J. But sometimes analysts might want to estimate covariance based on historical data, and in that case we use the sample covariance. The sample covariance is the average value of the product of the deviations of observations on two random variables from their sample means. And here is the formula. Let's understand this through a very simple example. Say we have stock I and stock J, and we have a very small sample. So we have return data for I and J, and let's say for I the return data is 5%, 6% and 7%, and then in the corresponding periods the return data for J is 7%, 9% and 11%. So here the sample mean for I is going to be 6%, sample mean for J is 9%, and now you can see how this formula is used. So for I in a given period, we take the value, and that's 5% initially, minus the mean, which is 6%, multiply that by the return for J, which is 7%, minus the mean for J, which is 9%. We do the same for the other values. So these two values, then we add the three products. So that's what this summation is doing. and then we divide by n minus 1. That is what gives us the average. In general, when we are calculating a sample value, as we do with sample variance, we divide by n minus 1, and there is a statistical reason for that which you don't need to know. But bottom line is that just like we have a population covariance, we also can calculate a sample covariance. This is the formula for the sample covariance, and the key point to remember is that here we divide by n minus 1. So to summarize what we've talked about, covariance is a measure of how two variables move together. The value will range from minus infinity to positive infinity. We'll have positive numbers if the variables move up together and then down together. The covariance will be negative if the two variables tend to move in opposite directions. The main issue with this measure is that it is difficult to interpret. So on the previous slide, where we came up with a number of 0.0066, it is hard to say whether the covariance is strongly positive or not. To address that problem, we use another measure called correlation, which is a standardized measure of the linear relationship between two variables, and the values or correlation will vary between -1 and +1. A correlation of +1 means that there is perfect positive correlation. A correlation of 0 means that whether this stock is going up or not has no bearing on what the other stock is doing. So connecting back with material that we saw in probability, a correlation of 0 would mean that the two events, stock A going up and stock B going up, are independent. The formula for calculating correlation, and this symbol is the symbol for correlation. So correlation is equal to the covariance between the returns on the two stocks divided by the standard deviation of the return on the first stock multiplied by the standard deviation of the return on the second stock. So you need to remember this formula. If you are given the covariance and the two standard deviations, you can compute the correlation. From this formula, you can also see that covariance between the returns on two stocks is equal to the correlation times the standard deviation of the first stock times the standard deviation of the second stock. So this formula is important to memorize. It allows you to move between covariance and correlation. Just to understand how to calculate correlation, let us take the same data which we saw a couple of slides ago, and let's compute the correlation. You have already calculated the covariance, and let us say that you now also calculate the standard deviation of A and standard deviation of B. In the previous lecture on this reading, we talked about how to calculate the standard deviation of variables such as this. You can use the calculator method or you can use the longer formula, but essentially when you compute the standard deviation of these returns given the three different probabilities, you should get 5.48% or 0.0548. The standard deviation of B is 0.1249. Given these numbers, you simply plug into the formula and you come up with a correlation of 0.97. Notice that this correlation of 0.98 is very close to 1. And this tells us that the correlation between the two stocks is very strongly positive. So it is almost 1. And this number is much more meaningful than 0.0066. 0.0066 is simply telling us that the correlation is positive. It is not telling us how positive or how closely the two variables move together. But a 0.98 number tells us that the correlation is very strong. And simply looking at the data over here gives you a sense. Now it is your turn to solve a practice question. You have two companies, Lemon and Demon, and they have the following probability distribution in different situations. you need to compute the covariance of the expected returns. Here is what you are supposed to do. First, compute the expected return of L, then the expected return of D, and then using the formula or the method that we talked about, you come up with the covariance. Next, for the same data, you need to calculate the correlation. And here, all you do is come up with the covariance, which you did on the previous slide. You have to then compute the standard deviations for both stocks. Correlation divided by the product of the standard deviations should give you 0.99. So this is saying that the two stocks are very strongly correlated. Now we are in a position to talk about both expected return and variance for a portfolio. Let's say that I have a portfolio that consists of two stocks, Oracle and Mindtree. Oracle represents 60% of the portfolio, Mindtree the remaining 40%. Oracle has an expected return of 12% and a standard deviation of 16%. We also have the expected return and standard deviation for Mindtree. We are told that the covariance between the returns on the two stocks is 0.0269. So what is the expected return for the portfolio and what is the variance? In this simple portfolio, I just have two stocks, Oracle and Mindtree. This is 60%. This is 40% of my portfolio. So the expected return on the portfolio will be the weight of the first stock, which is Oracle, so that's 0.6, multiplied by the expected return on Oracle, which is 12%, so into 0.12, plus the weight on the second stock, which is 0.4, multiplied by the return that is expected on the second stock,
which is 15% or 0.15.
So we do the maths and we get
13.2%.
Next, let's compute the variance of the portfolio. So given this overall portfolio of two stocks, what is the variance of the returns on the overall portfolio? And here is a formula that you simply need to remember. It will be useful here and it will be much more useful when you study portfolio management later. The variance of the portfolio is given by the weight of the first stock squared. So in our example, the weight of the first stock is 0.6. You need to square that. Multiplied by the variance of the first stock, you are given the standard deviation of 0.16. You need to actually take the variance. So you do times 0.16 squared plus the weight of the second stock squared. The second stock is Mindtree. The weight is 0.4. So we have 0.4 squared. And then the variance of the second stock, which is 0.24 squared, plus 2 times the weight of the first stock times the weight of the second stock. So 2 times 0.6 into 0.4 multiplied by the covariance between the returns on the two stocks, that is 0.0269. You do the calculation and should get 0.0313. This is the variance of the overall expected returns of the portfolio. If you want to compute the standard deviation, all you do is take the square root of that number and that will give you 0.177, which is 17.7%.
We've talked about the covariance between two variables and the correlation. A scatter plot is a graphical representation of correlation. In a scatter plot, each observation is represented as a point and the points are not connected. So let's say we have this picture where the return on stock I is represented on the x-axis, the return on stock J is represented on the y-axis. So in a given period, this is the return on I and this is the return on j. So we plot these returns for different periods and that gives us a scatter plot. If we have a relationship such as what is shown here, this would be considered a positive correlation because in general, when we have relatively high returns for stock I, we also tend to have high returns for stock J. Over here, we have a negative correlation because when we have relatively high returns for I, we have somewhat low returns for J. And in this case, we have no correlation because the return on stock J does not seem to depend on the return for stock I. So these are different scatter plots. You need to be able to look at scatter plots and determine whether there is roughly a positive correlation, a negative correlation, or no correlation. We also need to understand the limitations of correlation analysis. Correlation only assesses the strength of a linear relationship. So if we have two variables I and j and there is a relationship like this between I and j. This is a very strong relationship, but it is not a linear relationship. Therefore, when we calculate the correlation between I and j, we'll get something close to zero. The next limitation is that the correlation coefficient is sensitive to outliers. And this is illustrated over here. Let's say that we have X and Y data that looks roughly like this. Now, if we calculate the correlation, we will come up with a certain number. But then let's say that we have this huge outlier over here. The correlation number that we will calculate will be impacted by this outlier. And that's the point being made here. The correlation coefficient is sensitive to outliers. The third point is that a strong correlation does not imply cause and effect. So if we say that we have I and j and the correlation is, let's say, 0.9. So this is a strong correlation. This doesn't mean that we can predict the value of j based on I. So there are several possibilities here. A strong correlation might mean that I can predict j. It might mean that j can predict I, or there might be another variable x which is related to both I and j, and the high correlation might be because of this third variable. So a strong correlation does not imply a cause and effect relationship. The fourth point is that the correlation can be spurious. So we might have a relatively high correlation that we calculate based on a given data set, but that high correlation might be purely due to accident or chance. So it might just be that in a particular data set, it turns out that two variables appear to be highly correlated. But when we look at some other data, the relationship between those two variables might be quite different. So that's the fourth point. Correlations can be spurious.